Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on measurements and uncertainties from October-November 2021 paper 2-1. The main purpose of this video is not to give you answers for these questions. In fact, the main goal of this video is to teach you how to answer this type of problems. In today's lesson, we are looking at October-November 2021 paper 2-1, and total time for this exam is 1 hour and 15 minutes. You need to answer all the questions in this paper, and the total mark for this paper is 60. On the second page of exam paper, you can find values of some important constants. Let me highlight some constant you need for AS physics exam. The first one is the speed of light. The speed of light is very important because in exam often they will ask you to calculate the frequency of electromagnetic waves. So for that purpose you need speed of light. Means the speed of electromagnetic waves in air are in free space, and speed of electromagnetic waves in air are in free space is almost same. So then simply you can use V is equal to F lambda and you can calculate frequency if the wavelength is given to you. It's a very common question, so you have to be clear about this one. And the second important constant is the charge on single electron, and this is also called elementary charge. Means the charge on proton, charge on electron is the same, so we call this is elementary charge because this is the smallest possible charge on any particle. Means independent particle can exist independently, so this is the elementary charge. Quark has charge smaller than electron, but quarks do not exist individually, so that's the reason we call this is elementary charge. The second constant maybe you need, that is 1 joule. So this is 1 AMU, means atomic mass unit, and this is about the mass of proton. And next one is the mass of rest mass of electron, so this is also very important, you will need for some calculations. And the mass of proton is also very important in exam. If they ask you to use mass of proton, this one you have to use. Last important one can be the G, value of G. At AS level in paper 2 you have to use G is equal to 9.81, not 10. In the final CIE exam you will also find a list of important formulae. These are some basic formulae. If you can remember them, is wonderful. Otherwise, they will be given to you in your final CIE exam. The first formula is for uniformly accelerated motion. It simply means that you can only use this formula if acceleration is constant. Means A is not changing with time. You can only use this one. So this is very important point. You need to understand what is condition for this one, when you can use this. Only if A is constant. And the second important formula will be given to you is about work done by a gas. So this is work done by a gas, and this is only true, this formula is only true if the P is constant. So P is the pressure here when this is constant, so we can only use this one if the pressure of the gas is constant but volume of the gas is changing. And the next one is P is equal to rho GH. This is also important one. H, often student they confuse with this one. H is depth, it's not the height actually, so better way to say this one is depth. And the next important formula you need for AS physics is Doppler effect. So this formula, if you look at denominator, is written plus minus. So it simply means that when the source is approaching, so observed frequency will be equal to the frequency of the source time the speed of the sound divided by V minus Vs when the source is approaching. So this is when the source is approaching. This formula is only for when source is approaching. So this is very important one. You can also find observed frequency, that will be equal to frequency of the source times V speed of sound, and this is divided by V plus Vs. S is the speed of the source. So let me highlight here, in this case S is speed of source, so this is speed of source, the source, so this is for speed of source. And V here is the speed of sound, so this will be given to you, speed of sound. Fs is frequency of the source, so frequency of source, Fs. F naught here is observed frequency, means the frequency heard by observer, or simply we can say observed frequency. So this is observed frequency. Now simply you can see this is for when the source is moving away. When the source is moving away, you can use this one. But this formula is only true. Our assumption in this formula is that observer is at rest. Mean observer in this case is not moving. So observer at rest. So this formula is true for when observer is at rest. Let's move on to next one. Next important formula you need is electric current. I is equal to A N V Q. Very important one. Most of the time there will be one question about this, so you have to be very clear with this one. And the next two, resistors in series and resistors in parallel, these are very basic formulae, but they are also given to you and you need for some calculations. And that's all. These are the formulae you need for AS exam. For part A, simply we need to define density. Very simple question. So if in exam they will ask you to define density, simply you can say density is equal to mass per unit volume. So simply you can write down mass per unit volume, and that's quite enough to get 1 mark. Mass per unit volume, and this is B mark. It means it has to be in your answer. So this question has 1 B mark, means it has to be in your answer. For part D1, we need to state the name of measuring instrument suitable for making measurement of L. And L is given here with absolute uncertainty. So the best way to answer this problem can be, we can convert this one into centimeters. So L in this case is given to us. This is equal to 0.1242 meters. We can convert this one into centimeters. So simply we need to multiply with 100. So this will be equal to 12.42 centimeters. Now let's try to understand different type of instrument. The first common instrument used in lab is micrometer screw gauge. Micrometer screw gauge. We can simply write down micrometer screw gauge. So we have to understand 2 points about this one. The first thing we need to understand is that what is the maximum length we can measure with this one. The maximum length you can measure with micrometer screw gauge is 25 mm, or simply you can say this is about 2.5 centimeters, and the precision of this one is 0.01. The precision of this one is 0.01 mm, or we can simply say this is 0.00001 meter. So this is the precision of micrometer screw gauge. Next common instrument used in physics lab is vernier caliper. Next one is vernier caliper. So let me clean first of all. So the next one commonly used in physics lab is vernier caliper. Let's try to understand a little bit about vernier caliper. Vernier caliper, the maximum length we can measure with vernier caliper is about 15 centimeters, and the precision of this one, precision of vernier caliper is 0.1 mm. So this is 0.1 mm. Commonly used, we are talking about the commonly used. Even some vernier caliper, the precision is higher than this. If we convert this one into meters, so this will be equal to 0.001 meter. So this is the precision of vernier caliper. Meter rule is also one instrument commonly used in physics lab. So for meter rule, the maximum length we can measure with the help of meter rule, this is 100 centimeters, or you can say simply 1 meter. And the precision of this one is about 1 mm. So the precision of meter rule is 1 mm. If we write down this one in meters, so we can say this is 0.001. So this is the precision of meter rule. Now we have to choose the best instrument among all these. So these are 3 common instruments used in physics lab. But if we look at the vernier caliper, first of all, let's look at micrometer. We cannot use, because this can only measure up to 2.5 centimeters. So it means we cannot use this one. If we look at meter rule, the precision of meter rule is less than the precision of given data. So we cannot use meter rule. So only possible instrument we have now, this is vernier caliper, and this can measure up to 15 centimeters. That's wonderful, because this measurement is only about 12.42 centimeters. And the precision of this one is 0.0001 meter, means up to 4 decimal places if the unit is meter. So this is also true for this one. So it means we can simply write down for this one, we can use vernier caliper. So our final answer will be vernier caliper. So we can use vernier caliper. And this question has only 1 mark, and that is B 1 mark. Mean if you simply write on vernier caliper, you can also write on digital caliper. Still, you will get this mark. I hope this point is clear to you now. Next time, you can handle this type of problems very easily. For part B2, we need to determine the percentage uncertainty in the measurement of R. For R, the reading taken by instrument is given and the absolute uncertainty is given. So simply we can rewrite this one. We can simply say R in this case is given and R is equal to 0.0420 meter, and this is the reading taken by instrument, or simply you can say the measurement. And absolute uncertainty in R is given, that is 0.0004 meter. Question is asking us to calculate the percentage uncertainty in R. So first of all, let's try to understand from fractional uncertainty. So we will understand fractional uncertainty means U for uncertainty, and this is equal to absolute uncertainty. Absolute uncertainty divided by the measurement itself, or the best value of measurement if you have more than one readings. So divided by measurement. Now, if we have fractional uncertainty, we can also convert this one into percentage uncertainty. Simply, we need to multiply right side with 100. So simply, we can write down absolute uncertainty. Again, you can write down. So this is absolute uncertainty divided by measurement itself, as I mentioned before, or divided by the best value of measurement. If you have more than one measurements, or you have taken more than one readings, and this one you have to multiply by 100. So this is how you can calculate percentage uncertainty. Now let's try to calculate percentage uncertainty in R. So we can write down here percentage uncertainty in R. Simply this will be equal to delta R divided by R, and we have to multiply this with 100. Now we can simply plug in values. So delta R is 0.0004 and this is divided by 0.0420, and this is multiplied by 100. If we calculate this one, our answer will be about 1%, and this is the answer for this question. And this question has only 1 mark, and this is answer mark. If you got right answer, you will get this mark. For part C, it is given to us that density of the rock is equal to mass times R to the power of n divided by K times L. It is also given to us that n is an integer and K is a constant with no units. But you have to be very clear, some constants they have unit, but K is a constant and this constant has no units, and its magnitude is equal to 2.094. We need to use SI base units to show that n is equal to -2, or simply you can say -2. How we can answer this question? If we look at this equation, actually this is a homogeneous equation, so it simply means that units on the both sides of this one are the same. Means the units on the left side are equal to the units on the right side. So we will use this principle and we will try to answer. So first of all, let me rewrite this one. So m times R to the power of n. R is the radius, m is the mass, K is a constant and it has no units, L is the length. K has no units, so simply we can ignore that one, so we can rewrite this. So this is m times R to the power of n simply divided by L. Now we can write down the units. SI unit for density is kg per cubic meter, and SI unit for mass is kg. SI unit for radius means for length, this is meter, and its power is n, and the unit for L is m, so this is m. Now we can further simplify. We can write down this is kg and m to the power of n, but when you take this to numerator, so its power will be -1, because here is +1, here will be -1. Now we can rewrite this. So we can write down kg per cubic meter. This is equal to kg m to the power of n minus 1. Now we just need to simplify this one. So if you look at this one, you can see kg is on both sides. So simply we can cancel this one. And we left with m to the power of negative 3 is equal to m to the power of n minus 1. So simply we can say in this case minus 3, this has to be equal to n minus 1. Now simply if we further simplify this one, we can simply say n in this case will be equal to minus 2. So this is our final answer. So this is minus 2. This is what question was asking us, to show that n is equal to minus 2. The first mark is if you have written these SI units, so you will get first mark. And this is M mark, means it has to be in your answer. And the second mark is answer mark. If you have got right answer, you will get the second mark. But if you couldn't get this mark, only you write the answer, n is equal to minus 2, you will get 0 mark. For the second part, we need to calculate the percentage uncertainty in density. And the density means the formula for density is given to us. This is how we can calculate density. Density can be calculated by multiplying these quantities and dividing. So this is simply telling us quantities are multiplied and divided. So we need to simply add percentage uncertainties of these quantities to calculate percentage uncertainty in density. So let me write down what I said. I simply said that if you need to calculate the percentage uncertainty in density, this will be equal to the percentage uncertainty in M plus the percentage uncertainty in R. We will talk about exponent later, plus the percentage uncertainty in K. But K is a constant, so you can ignore that. So next one, you can say percentage uncertainty in L. So K is a constant, it has no percentage uncertainty. So the percentage uncertainty in density is simply equal to delta M divided by M, and you have to multiply this one with 100. So this is how you can write down percentage uncertainty in M plus percentage uncertainty in R. So that simply is equal to delta R, mean absolute uncertainty, divided by R, and it has to be multiplied with 100. So we will multiply this one with 100. So it has to be multiplied with 100. But you also need to understand, we have the power of this one. The power is n, and n is negative. So n is negative, we have calculated. But here you have to enter this one plus 2, because uncertainty cannot be negative. So very important point. So uncertainty cannot be negative. So it has to be plus 2, not minus 2. And next one, the percentage uncertainty in L. So this will be delta L divided by L, and we need to multiply this one with 100. Now simply we need to plug in values and we can calculate our final answer. So in this case, delta M is 0.001 divided by 1.072. We need to multiply this one with 100, plus we have 2, and delta R in this case is 0.004, and this is divided by 0.0420. We have to multiply this with 100, and plus we have delta L. Absolute uncertainty in L is 0.001 meters divided by 0.1242. We need to multiply this one with 100. And now we just need to simplify. If we simplify the first one, our answer will be 0.09%, and for the second one we have to multiply with 0.95%, and the last one is 0.08%. If we add all together, our final answer will be about 2.1%, or simply we can say 2%, and this is our final answer. This question has 3 marks. The first mark is if you have written in this form, you will get 1 mark, and this is C mark. And the second mark is if you have plugged in these values, and the last mark is answer mark. If you have got the right answer, you will get full marks. So this point is tricky one. It has to be plus 2, not minus, because uncertainties never be negative. Uncertainties are always added, not subtracted. For this part, we need to determine density with its absolute uncertainty. And it is also given to us, give your values to the appropriate number of significant figures. So we have to take care of significant figures as well. Otherwise, we will lose marks. Now let's start from density first of all. Density we need to calculate. And formula for density is given. This is equal to mass times R to the power of N divided by K times L. The M is given, so simply you can read from here. Value of M is 1.072 and the value of the radius is given. So this is radius. So simply you can write down this is 0.0420 and the power is N and the value of N is -2. And this is divided by k. K is a constant and the value of constant, it is given in the question, that is equal to 2.094. Its value is given to us and the value of L you can just read from here. So L is 0.1242. You need to use calculator and you can find the value of density. If you do calculation, so your final answer will be this. And the unit of density means SI unit is kg per cubic meter. So all the quantities are in SI units. Now the next thing what we need to do is we need to calculate absolute uncertainty. But the percentage uncertainty we have means we have delta rho by rho. The percentage uncertainty we have, that was equal to 2.1%. So this value we have. Now we need to calculate delta rho. So simple way is that divide right side by 100. So simply if we divide this one by 100, so this is now fractional uncertainty. If you go from percentage uncertainty to fractional uncertainty, simply you need to divide by 100. So this is divide by 100. Now we have fractional uncertainty. We need to calculate delta rho. So it simply means this is 2.1 divided by 100. We have to multiply with density. The value of density we just calculated. Just multiply with this. And our final answer in this case, this will be equal to 49 kgs per cubic meter. I mean, this is the absolute uncertainty in density. Next part, we need to write down this density with absolute uncertainty. So you can see this quantity. If you look at this one, this has 4 SF. So this has 4 SF. If you look at these quantities, this has 3 SF, this one has 4 SF, this has 4 SF, this one also has 4 SF. So this quantity has the least number of significant figures. So in our final answer, this can have least number of significant figures or one more. So we can write down this one up to 3 significant figures. So simply I can say this is 2340. So this has 3 significant figures now. So 3 SF. Absolute uncertainty, we have to write down up to 1 SF only. So this one we can simplify to 50. Now let's try to write down our final answer. So the final answer you can simply write down like this. This is 2.340 plus minus 0.050 kgs per cubic meter, and this will be multiplied with 10 to 3. So this is our final answer. This is how you can write down. Simply you can write down here. You can say this is 2340 and this is 50. Now let me explain to you how marks will be awarded. The first mark will be awarded, so this is C mark, and the second C mark you will get if you got this answer for absolute uncertainty, and the last one you will get if you have written your answer in this form. The main concept what you need to understand is how to write down quantity, mean this quantity and the absolute uncertainty. The simple way is that first of all you have to understand this absolute uncertainty, it should have 1 SF only. And the next point you need to consider is the number of decimal places. How many number of decimal places are in absolute uncertainty? Same you have to use in this measurement. So they must have the same DP. If you follow these rules, you will get full marks.